Okay, if I'm going to be honest with you guys, it's kind of like we're getting into a hot bathtub with hot water in it. So we're easing into the unit circle, and this is the next part of where we're going to have to familiarize ourselves. And that's what happens if you think about triangle on the coordinate plane. This being quadrant one. So if you let p, x, and y be a point in a plane that forms an angle theta, remember theta, with the positive x-axis, let the distance from p to the origin, be given by r, and let side PO be the terminal side of angle. So that means that if we start the angle from here and we rotate up, we're going to have the terminal side being created by that. And so we're going to have obviously a right triangle. For any point xy in the plane, the cosine of theta, remember that's adjacent over hypotenuse. The cosine of theta is adjacent over the hypotenuse, which is r in this case, right? Because it's a radius of a theoretical circle, and so we're going to use that further. And if I look at that, the cosine of theta equaling x over r, the sine of theta must be the opposite y over r. All right, so if x plus y squared equals r squared, r greater than 0, you have everything you need to start the unit circle. Let me explain this one a little bit more detail before I move on. Okay, so this is the first quadrant. And the reason we talk about things like the unit circle, the reason that even is a concept is because if I were to, no, not this shape. You see, this is normally the shape I don't want, and now it gives it to me. This is a unit circle, if you follow that logic. So a unit circle is called a unit circle because the radius we take to be 1. So when we look at that r that was in the prior picture, we're going to give that a 1 measurement. Unit circle number 1. And then what we're going to do is create a right triangle based on that. And that means that we're going to need to drop a perpendicular from this point down to here. All right, and I guess I'll give it a color. I guess I'll give it a red. Okay, so that's a perpendicular. And you know, like usual, there's going to be a horizontal, and we're going to start that from the origin and bring it over. I can't really make it out. Maybe I need to try one more time. Let me see if that works this time. It may not work because it overlaps a little bit. Let's see. Okay, so this is what we have here. And I'd like to look into what this means. Look at it for a second. And now we're going to break this down. We're going to really, really get into the nitty of it. So if this is 1, right, and this is, say, the distance I travel out to x. So this would be my distance x. That would mean that this is my distance y. And if I then travel to this location, that coordinate would be x and y. All right, and if it's a 2 and 3, this would be 2, 3, for example, you know, basic thing. But it's not here in this case, but it helps to understand what we're doing here. And if I did Pythagorean theorem, I would know that x squared plus y squared will be equal to 1 squared, or 1, which is something that we discussed earlier. X squared plus y squared is equal to 1. Now, if I have an angle here marked off as theta, and I want to ask myself what the cosine of theta is, the cosine of theta is the adjacent over the hypotenuse, right? But the hypotenuse is 1, so it's just the adjacent, and that's x. Same thing for sine. If I do the sine of theta, is the opposite, which in this case is y over 1, but I don't really need to mark the 1. So this is what I end up with. I get cosine of theta being the same thing as saying what is the x value. The sine of theta would be the same thing as saying what is the y value. All right, and that's going to really, really be useful to us when we start using the unit circle. All right, our next step would be to see what happens if I replace that theta with 45. That's our next goal here. And that means that we're going to now evaluate, based on what we know from the prior video, what happens here. All right, so remember that in a 45, 45, 90 triangle, first of all, and this is why we studied that in the first place. If this is 45 and this is 45, and this is the hypotenuse, that means that x and y became 1. X squared plus y squared equals 1. x squared plus y squared is equal to 1. But as I said before, if this is the same length, we can just do 2x squared is equal to 1. X squared would be equal to 1/2, and x would be the square root of 1/2, which is going to become, long story short, square root of 2 over 2. So for the 45, 45, 90 triangle, y is square root of 2 over 2, and x is also the square root of 2 over 2. You're going to want to remember this big time. I'm telling you, that's just huge, huge, huge important. Okay, so that's the first thing. And now we can go ahead and figure out what our relationships are. And remember, this is the location here is actually correct. It's square root of 2 over 2, comma, the square root of 2 over 2. So when I say that I'm looking at the coordinate, I'm saying the x coordinate is radical 2 over 2, or 0.707, and this is 0.7072. So roughly on the unit circle, this is where it would fall. All right, that's good, because we're going to need this, right? We're going to put two more of these things together to come up with the quadrant of the unit circle. And now, if I asked you what the sine of 45 degrees was, you would tell me the y coordinate, which is square root of 2 over 2. And if I asked you what the cosine of 45 was, you would tell me the square root of 2 over 2, because it's the x value. Remember, cosine is x and sine is y. All right, and then the tangent would be the opposite over the adjacent, or the sine over the cosine, but in any case, the tangent of 45 is 1. All right, and the calculator will verify all of that just by going here. I'm going to do all three of them so we can see that's going to happen. The sine, wait a minute, give me a second. Okay, sometimes when it's sleeping for a while, it doesn't behave right away. So sine of 45 is 0.707. Gotcha. The cosine of 45 is also 0.700. And a tangent of 45, like we did before in our testing, is 1. But that's why it's 1. It's something divided by itself. All right, so now we're going to leave this here, and we're going to move into the next important angle here. And like, as this was based on the 45, 45, 90 triangle, this was going to be based on the other one. This is going to be based on the 30, 60, 90 triangle. It's jumping forward a second. Okay, so for this one, we're going to use the relationships that we developed earlier before as well. And for that, we're going to just remember the relationship that were really useful for us in this case. And that is that this is 30. That means that this is 90, which it is, obviously perpendicular. And that means that this is 60. All right, and remember what we talked about, that 60 degrees constitutes a critical angle, where it's going to be twice the this is going to be half as long as the hypotenuse, or the hypotenuse will be twice as long as the side on the opposite side, on the other alternate side of 60. That means that y is easy in this case. It's going to be 1/2. Okay, y is 1/2, and that means that if this is the side, this is 2 times the side. This is side radical 3. That means that x is equal to 1/2 radical 3, or radical 3 over 2. All right, that means I have different coordinates up here, so I need to erase this because it is no longer x and y. We now know what the values are, and we can put them in their right positions. We know that the x coordinate will be square root of 3 over 2, and the y coordinate will be 1/2. Now, in terms of what that means in the trig ratios, the cosine of 30 degrees is radical 3 over 2. The sine of 30 degrees is 1/2. All right, and the tangent, okay, sine over cosine, right? So let's see, the cosine would be radical 3 over 2, or 0.866. The sine, that's the cosine. The sine is 0.5, right? 1/2. And then what happens if I divide sine by cosine? In other words, 1/2 divided by radical 3 over 2. That'll be 1 over radical 3, but that's more properly written as radical 3 over 3. Okay, so now we have our tangent here. This is our tangent. We just need to verify that that's correct. So we're going to go to the calculator again, and we're going to do what we did before. The cosine of 30 is 0.866, but that's square root of 3 over 2. Just to verify that, square root of 3 divided, no, it's not doing it. I don't know why it does this. It's weird. Divided by 2, and that's going to give me 0.866, just like we said it was going to do. We know that the sine of 30 should be 1/2, just so. And the tangent of 30. The tangent of 30 should be 0.57735, but that's supposedly radical 3 divided by 3. So if I multiplied it by 3, I should get the 1.7321, and you can see that that all checks out. So we are correct about this, and I'm just going to summarize it on the left, on the bottom. The sine of 30 is equal to, what would we say it was? It was going to be radical 3, no, 1/2. Wait, the cosine of 30, sorry. The cosine of 30 is radical 3 over 2. The cosine of 30. The sine of 30 is 1/2. All right, and dividing 1 divided by radical 3 over 2, that's going to give you the tangent of 30, which is equal to radical 3 over 2. And again, we're going to need all of these values in the future, so it's good to practice this. And we'll do a summary also. And I'll give you a way to remember all of this. Next one is the 60-degree angle. Again, exact same situation. We've got 60 here, but not in any particular thing. And you'll notice what happens is that the critical angle has shifted from here to here, which changes our relationships too. And that'll require a little bit of thinking. So if this is 1, this is the critical angle, that means that x is now 1/2. And I know that if I flip 30 and 60, I would get the opposite value. This is be radical 3 over 2. So they flip positions. If you compare it from the earlier one, and now I can get all 3 values. That means that I no longer need x and y here as a placeholder. I can actually put the real values in, and I'm going to do that right now. They're just pop this in. Okay, so the cosine of 60 is the x value, or 1/2, and the sine of 60 is radical 3 over 2. And remember, it's sine divided by cosine, or opposite over adjacent. It doesn't matter what you'd want to do for tangent of 60. It would be radical 3 over 2 divided by 1/2, and that becomes a radical 3, a full-on radical 3. That's 1.7321, right? 1.7321. And I can now summarize those. The cosine of 60 degrees is 1/2. The sine of 60 degrees is radical 3 over 2, or 0.866. And the tangent of 60 is the square root of 3, which is 1.7321. Let's put that to the test. Go back up here. The cosine of 60, 1/2, check. The sine of 60, 0.866, also check. And the tangent of 60 would be 1.7321, which we know is also known as the square root of 3. So everything checked out, everything's fine. And we are now ready to combine all of these 3 things for the unit circle. So now we should take a look at what happens when everything combines together. All right, so let's take the easy one here, 45 degrees. We know this is 45 degrees. We know that for a fact, 45 degrees. We know that the x and y are square root of 2 over 2, square root of 2 over 2. We know that for sure. This is 30 degrees, because 30, then 45. This would be 60, and this then would be 90. Let's see what we have here. The coordinate of this location here is 1, 0, because it's a full length 1 that's perfectly horizontal. All right, and conversely, if we come up here, this is 0, 1, because those are 2 radii of this unit circle. And the rest of them are radii also, but they're not perfectly horizontal or vertical, so they're going to take some portion of it, but they're not going to be a complete thing. All right, now let's put this here. This we know is a little bit less than 1, right? And we know that's going to be the square root of 3 over 2, which is a little bit less than 1, 0.866. And this would be 1/2. This is in the prior screen. So we're going to now end up here, and this is close to 0, but it's not there. And it's a little bit out of proportion, but it would be 1/2. And this would be square root of 3 over 2. If for no other reason, then we know that it's the reverse of the 30-degree angle. Because if one angle is 30, the other one must be 60. Not like 45. When it's 45, they're both 45. But here, they're different. So you end up with 3 locations. You've got 30 degrees, radical 3 over 2, 1 over 2. You have radical 2 over 2, radical 2 over 2 for 45 degrees. And for 60 degrees, you have 1/2 and radical 3 over 2. and then finally you have 0. All right, so this is everything you need to know about the unit circle, because once I have this, I can duplicate this in all the other 3 quadrants and get my entirety of my unit circle just by remembering this screen. So I would look at this one really closely, and then I'm going to give you a way to remember it in a second. Here we go. The hidden secret for the unit circle is to take your fingers and have them act as duplicates for the different locations. Your pinky will be 90 degrees, or remember pi over 2 radians, right? Or 90 degrees, whatever you want to call it is fine, right? This is 1 and this is 0. So this is the x-axis. Your thumb will be the x-axis, and you spread your pinky and your thumb as far apart as possible. That makes this your 30-degree angle, or pi over 6. This makes 45-degree angles, or pi over 4. This makes 60-degree angle, and pi over 3, and pi over 2 like we have here. Now, the way you remember this is really simple. Just remember that you begin with the largest value for your x, so it's going to be 3, 2, 1, and then you're going to reverse track 3, 2, 1, and the first thing you want to do is put everything over a 2. Everything goes over a 2. And the last thing you're going to want to do is put anything that's not 1 or 2 in the top. Anything that's not 1 over or under a radical. So this would be a radical 3, this would be a radical 2, radical 2, radical 3. You end up with everything you need. You have 1, 0, you have 3, 2, 1, and then you have 0, 1. And that'll give you everything you need to know. I really recommend this one. 3, 2, 1, 1, 2, 3. 3, 2, 1, 1, 2, 3. And that'll give you a first heads up that you would want to really remember, because it makes your unit circle really easy. And as you can see, that'll give you all the values that you need for determining the major angles in quadrant 1. You have 30 degrees. Remember, that's 180 divided by 6, or pi over 6, that's 30. Pi over 4 is 45. Pi over 3 is 60. Pi over 2 is 90. Everything you have is done at this point, because once you have this is the best part about this whole thing. You can then reflect it to the different locations elsewhere. So I can now, let me start the circle. Let me see if I can grab the circle and recreate it from here. No, that's not working. I need to pull that circle tool out and go here. Okay, so this is my circle. Okay, and now I'm going to do line number 1. That'll be the equivalent of 60. Line number 2, that'll be the equivalent of 45, and line number 3, that'll be the equivalent of 30. And let's think about what these numbers are. All right, now remember that it went from 60 to 90, which means that this is a distance of 30 degrees here. If I add 30 here, this will put me at 120. And then remember that this is also 30 degrees away from the 180, which is pi. So I'm going to make that 150. And then this is half of 30 in either direction. That'll put this at 135. Now, in terms of what they are, let's ignore the 30 and 60. Let's just look at the 45s for a second. So I'm going to extend the 45 lines. I'm going to just bring them all the way from here to here, okay, into the last quadrant. And I'm going to bring this one all the way into the last quadrant down here too. So I don't really want to look at this for the moment. I'm going to move it out of the way. Maybe I'll hide it. I don't want to see it though. I don't want to see it. So I'm going to make it completely transparent. Okay. And I'm going to do the same thing for this one as well, because I want to focus on the 45-degree angles for the moment. Now, remember that we do pi over 4. This is 1 pi over 4. 1 pi over 4. And I'm going to bring this over. Okay, 45 degrees. 45 plus 45 is 90. 90 plus 45 is 135. So far, so good. And now I'm going to continue around the line. If I go from 135 to 45, I'll be 180. 180 plus 45 will give me 225. 225 plus 45 will give me 270. I think, okay, I have it, 270. But I need to extend this line to make a room for that one too. So I'm going to pull this down. Yep, I still have my color. I'm going to go here. Okay, so that's 270. Remember, everything's divided by 45 degrees. If I could continue that, that's going to bring me to 270. 270 plus 45 is 315. 315 and 45 will give me 360, or 2 pi. Now, What do they equal? What are their values? Well, this is 1 pi over 4. That's easy. This up top, it's a little bit big. I'm trying to fit the whole thing in one shot. Okay, 1 pi over 4. This is 2 pi over 4 at 90 degrees, but that's pi over 2. We got that one too. That would mean this is 3 pi over 4. 45 degrees extra would be 4 pi over 4, or just pi. So far, so good. This is 5 pi over 4. And then this is then becomes 6 pi over 4, or 3/2 pi, or 3 pi over 2, because you always want to reduce it. If this is 1, 2, 3, 4, 5, 6, this would be 7 pi over 4. And that is in fact correct. And then 45 degrees more would give me 8 pi over 4. 8 pi over 4, which is, once again, 2 pi. So this is really easy to do once you remember this. Again, 1 pi over 4, 2 pi over 4, or a half, 3/4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. If you do that, you will always get these values right. All right, and then there's going to be talk about reference angles and things like that. That's going to come up in one of the units, one of the exercises. Just remember that if this is 45 degrees here, which it is for our purposes in this case, well, this is also 45 degrees, right? Because it's just downward 45. So this is called a reference angle. A reference angle is the smallest angle that it's equivalent to. That's 45 degrees. Reference angle would here be also 45. And the same thing up here too, all right? So if I were to go down to my horizontal, that would be a 45 degree angle, or the equivalent of a 45 degree angle. So that's how I get anything. So now if I were to ask, for example, the cosine, no, the cosine, let's do the cosine. The cosine of 315 degrees. 315 degrees. The cosine of 315 degrees would be based on the fact that it's a version of the 45 degree angle, right? And I'm asking, another way of asking is, what is the cosine of 7 pi over 4 if they gave it to you too? All right, and that would mean that I would need to know what this location would be if I were to look at it in terms of that. And I think you can tell this would be the reflection of this down here. So that would be, let me make a red and blue just as the other ones are. This would be a radical 2 over 2, but because it goes down, this is a negative radical 2. Oh, I'll make it blue. It should be a negative radical 2 over 2 for my sine. Now cosine is radical 2 over 2. My sine is negative radical 2 over 2 because it reflected downward. All right. So I'm going to verify in the calculator that the cosine of 315 degrees is radical 2 over 2. So where's my calculator? Okay. The cosine of 315 degrees is radical 2 over 2, 0.707. And you see it's positive. If I were to do the sine, based on this, my prediction would be that it's going to be a negative number because it's in the 4th quadrant, which it is, but you see the numerical value is still identical, right? That's how everything works here. So one more check on that. I could see what the cosine of 3 pi over 4. The cosine of 3 pi over 4 would be the cosine of 135. And the cosine in this case would be negative because x is negative on the left-hand side. And the cosine of 135 would be a negative 0.707. This always works out really well. And one thing you can take away from that is that the sine of any number of this group would be either a radical 2 over 2, either positive or negative, or it would be depending on where in the quadrant it lies, which quadrant it falls into. Right, that's going to lead me to another discussion in a second. I might as well bring you to it now. You want to remember this as well. I'm opening up a new page. If I were to do a circle, I'm waiting for the tool to show up. I'm going to create another axis. I don't want it to be orange now. I want it to be black. I'm going to create another axis, and I'm going to create the unit circle for that axis, and that's going to require that I do this here. I'm just going to pull it over here. Let me extend it out. Okay, and okay. Now, one thing to remember is that, and this is really essential, is that in this quadrant number 1, x is positive and y is positive, right? Because we know that x is positive, y is positive. In quadrant number 2, though, that is not the case. X is negative because I moved to the left, and y is positive. In quadrant number 3, x is negative, y is negative. X is negative, y is negative. And in quadrant number 4, x is positive, but y is negative. Okay, now what does that mean? Let's look at this means. This means, for example, if I just look at my cosine is positive here, but it's negative here. It's negative here, and it's positive here, right? In the first quadrant, my sine is positive. In the second quadrant, it's also positive. In the third quadrant, my sine is negative. And in the fourth quadrant, it's also negative. So how to remember all of that? It's always a mnemonic because we love mnemonics. And the mnemonic for this one is all students take calculus, ASTC. What this means here is that in this case, literally, all the trig ratios are positive. Everything is positive here. But here, only the sine is positive. Here, only the tangent is positive because y divided by x, if they're negative, would give you a positive value, right? Otherwise, they're both negative. And in this case, the cosine is positive. So that's where that's coming from. So cosine is positive in the fourth quadrant. All students take calculus. That's your bestest buddy here, really. All students take calculus. Okay, so that's something to keep in mind as well. I'm going to talk about the 30 and 60 degree angles right now, just to complete this video. So our takeaway from all of this is that if I look at 30 degrees, radical 3 over 2 is my cosine, 1 over 2 is my sine. The reds are cosine, the blues are sines. That means that the cosine of 30 degrees in quadrant 1 is radical 3 over 2, which is 0.866. The sine would be positive 0.5. In the second quadrant, though, you see the x became negative. So my cosine of this equivalent value, 5 times 180 divided by 6, that's 150 degrees. So I know that my cosine of 150 should be a negative number from that. So let's verify that. The cosine of 150 should be a negative 0.66. Check, that works. And if you look at the third quadrant, the counterpart of 150, because I go 30 more to get 180, if I go 30 more, I get 210, right? And 210 degrees, let me think about this. This is pi over 6. Remember how we did it before? This is the same thing happening here. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. They all have pi's, piece of the pie. And then 6, and then this would be 5 pi over 6, which fit. It went right into it. This is 6 pi over 6, but that makes a full pi. That would mean this is 7 pi over 6. Check, that works. 8 pi over 6, which is 4/3. So if I go every 30 degrees, I'm going to be going in increments of 6. 1 pi over 6, 2 pi over 6, 3 pi over 6, and so forth. If I go around the 60 degree angle, I'm going to be traveling in increments of 3, because 60 is 180 divided by 3. So this is 1/3 of pi, right? Going 60 more from that gives me 120. That's 2/3 of pi. Going 60 more from there gives me 3/3 of pi. Going 60 more from there would be to 240. That's 4/3 of pi, or 4 pi over 3. You follow? And then skipping over this again, 60. 240 plus 60 is 300. That's 5/6 of pi. And then doing 60 more from 300 would take me straight up to 360, which is 6/6 of pi. Everything fits, okay? But you do have to go slowly about this and understand the relationships. Again, here, you see every single thing is positive here. Here, the cosines are negative, the sines remain positive. Here, everything flipped into negative. Here, the cosines became positive. This is your unit circle. And once you have the unit circle mastered, you can start answering questions based on the unit circle. There's some. And it also helps when we start graphing the sine waves and the cosine waves. All right, so I think I've covered enough here without blowing your heads around. You do want to do a little bit of supplemental reading of this if you want to, and hit me up with any questions you may have. This one is a little tricky. I'll talk to you soon.